All right. Well, I'm going to talk about the Trace API. It's a new way to monitor a Firebird database. So who of you is already using Firebird 2.5? Okay. The Trace API is a new feature in 2.5. Even if you don't use 2.5 yet, it might be useful for you to use it as well, especially if you're going to probably using 2.5 in a test environment or something like that, just to use the Trace API. Well, that's pretty much the agenda. We are talking about the motivation. Why is the Trace API useful? Then I'm going to give you a short introduction into what monitoring approaches we have. Then I'm going more in detail what Audit and Trace Services API is. I'm going to show you a few examples with the command line utility, and I'm also going to present you the FB TraceManager product. Well, when talking about database monitoring, there are usually several stakeholders involved here. Either you are a database administrator, or you are a developer, or you're an auditor. So I guess most of you are developers, I think, or database administrators. It's pretty much useful for some kind of roles in a project with Firebird. Well, if you are using Firebird 2.1, you probably already have used the monitoring tables. The monitoring tables is pretty much a stable snapshot of the current activity which is going on in the server. But usually to spot problems, to see what's happening, such a stable snapshot is can be useful, but you also might be interested in the history. So what has happened in the past, and you don't get that information with the monitoring tables. So basically, what you are interested in is a continuous monitoring approach, which basically gives you a stream of executed events over a period of time. Just the ability to look back to what happened in the past. So there is a new way to detect and diagnose problems, and it's pretty much the Audit and Trace Services API in Firebird 2.5. There are many use cases where you can use the Trace API, where the first one is if you're interested in getting the number of executed statements for a particular time period, you can do that with the API. Just for instance, for some kind of usage statistics for resource planning or load planning. You can also do some kind of black box debugging. So if you have third-party products in your company, and you pretty much don't have the source code and you don't know what the application is doing, this is a perfect use case for the Trace API as well. And the good thing about the Trace API is that you don't have to add some kind of trace logic into your client application. So pretty much to start your application, work with the application, the Trace API gives you what's happening. There are other use cases like if you want to detect some kind of failed or unauthorized access, or if you're interested in certain event types like when did a commit transaction happen, when did a prepare statement happen, and so on. You can also detect some kind of if commit retaining is used over time. For instance, if you're in some kind of auto-commit mode in your client application, you can spot it very easily. You can also detect full table scans. So if you are wondering why your statements are slow, you can inspect the execution plan of such statements. You can also detect what is the most frequently executed statement. So if you're interested in basically spotting the 5 most frequently executed statements and do some optimization on them, you are able to do that as well. You can also spot the worst performing executed statements. So you have, if you have a few slow statements, you can easily detect them with the API. And of course, some kind of given threshold. If a particular statement is slower than, let's say, 5 seconds, you can do that as well. And you can generate some statistics like what was the number of executed statements per IP address, per remote process name, per user, and so on. So you basically can detect what is the most loaded database on the server if you're running more databases on your server, when are usual peak loads and something like that. So there are a lot of use cases where you can use the Trace API. Well, before going into some detail, I just want to do a very short demonstration. We are discussing the things in more detail afterwards. Just to get an impression what the Trace API is delivering. So basically we have a command line tool included in Firebird 2.5 now. I'm connecting with the services API with a user and a password. I want to start a trace session. The trace session has a trace session name, and you have to provide a configuration file. The configuration file itself is rather small. For instance, you just have a few configuration parameters. You want to trace one particular database. It is enabled. You are interested in tracing connection activity. You are interested in transaction activity. When gets a statement prepared, when gets a statement freed and start and finished. So basically, it's just executing this batch file. So what you get here is just a textual output here. And let's say if you're going to execute something over here, select star, you get some kind of, you get the trace what happened. So that's basically the idea what the Trace API is. You start the trace session, activity happens, and you get immediately feedback on what happened regarding trace session. Well, let's go into more detail now. There are basically you have several monitoring requirements. One requirement might be it is continuous. The other one is server-side, because you don't want to expand your client application with some trace logic, and it should be configurable. Well, out of the box, Firebird 2.5 to date has 3 approaches. The one is trigger-based. We have that pretty much from the beginning. The monitoring tables, and last but not least, the new Trace API. Usually in practice, you probably use a mix of them. So, for instance, trigger-based and audit trace if you want to know the old and new values, if you change some kind of values. So, just a quick comparison here. It's basically all of them are server-side, so that's good news for the client application developers. The monitoring tables are not continuous, so every time you query the monitoring tables, you get a current snapshot of it. So the monitoring tables are also not configurable. It's pretty much a fixed set of tables and columns available. You can query. Pretty much with a trigger-based solution, you can monitor select statements and can trace deleting adaptive statements with all 3 approaches. What you don't have in the monitoring tables in the Audit Trace Services API, if you are changing data, the trigger-based solution is the only one available which can give you the information. On the other side, the Audit and Trace Services API is the only solution which gives you access to the statement execution time and the statement execution plan. And monitoring of database-wide operations like connect, disconnect, transaction start is the Trace API the ideal solution. So as you can see, there are quite some difference here. So it's pretty much in practice, it's a mix of these approaches you probably will use for monitoring the database. All right, let's go into the Audit and Trace Services API now. The good news is that available across all architectures, across all operating systems, across 32 and 64 bits. So whenever you are able to run Firebird 2.5, you are able to use the Trace API. It allows to produce a trace of events in a chronological sequence, so you have really the timeline of what happened, and you can look back to the past. There are specific event types you can configure when you're starting a trace session. For instance, if you are interested in database-specific events, you can do that by providing the proper configuration parameter. For instance, you are able to trace connect, disconnect, start, commit, rollback, prepare, statement, finish, free. So there are quite some configuration parameters here available for tracing database-specific events. On the other side, if you are more interested in server-wide events, like when did a database got backup or restored, or if when did someone query the server log or something like that, there are also the server-wide trace events which you can use if you are not interested particularly in some database operations, but in server-wide operations. When working with the Trace API, you have to take into account that there are basically two ways to use it. There is the system audit and the user trace. Then the main difference here is that the system audit will be automatically started by the engine when the Firebird server starts, so you don't basically have to start the trace session manually in this case. So every time you start the Firebird server, the trace session automatically starts. It stores the trace output, the text output, what we have seen in the previous example on a text file on the server, and you pretty much have one parameter, one new parameter in the firebird.conf file, which allows you to define the path to the trace configuration file. And one thing is that, of course, you only can have one system audit session per Firebird instance. On the other side, there is the user trace. The user trace needs to be started by the user manually, so you are responsible to start a user trace session. And the trace output you get is pretty much immediately when something happens. The Trace API sessions on the client side listens to incoming events, and what we have seen in the example before, you get the trace output back on the screen, for instance. The thing is that as it is a user trace session which you have started manually, after a server crash or restart or something like that, you have to restart your user trace session again. And the good news is that depending on possibly on your configuration, the trace configuration, on the parameters you are interested in, you can start more user trace sessions per Firebird instance. Well, it's Alex Peshkov already talked about plugins. The Trace API plugin is basically comes per default with the Firebird installation. There is one on Windows, one FB Trace DLL or FB Trace SO on POSIX. So, and it's pretty much a fixed text output format you can't influence. So you get something like that back. So as you can see, there is some information like the timestamp, some cryptic information here with the session ID, the event type, the various event types here, as you can see. And then depending on what event type we are talking about, you get detailed data here like the database, the attachment ID, the user, the role, the character set, what client IP address, the remote process name, process ID, and so on. So you get a lot of information per events type here. The trace configuration is a usual text file, a usual text information. So you have to customize that. There is you get one configuration file with a Firebird installation. It's called fbtrace.conf. It's pretty much lists all available configuration parameters with commands with description on what it is. So basically, what you do is when you're creating a trace configuration, is you basically define what you are interested in with database-wide events and server-wide events, and it usually consists of like it can consist of one default database section, and you can override the settings what you have made here with particular database sections below them. And there can only be one services section. The services section pretty much defines if you're interested in server-wide events, like if you're interested in getting some feedback when a backup has been created or a restore has been run. All right, a very simple example. Let's say we have our default database section here with enabled true. So in general, we are interested that a trace session that trace is enabled. We can override the settings here with database specific entries here. Then, for instance, for our employee database, we don't want to have a trace. For another one, we don't touch the enabled property here, so it's per default true then, and we are only interested in log connections here, so in connection establishment event types. There are a lot of configuration parameters. They look a bit well, they are not complicated. It's just a matter of going through the trace configuration file once and just read the commands a bit. There's also on the IB Phoenix website an article from me which goes a bit more in detail about these configuration parameters. And for the client, for the access components developers, there are basically 5 new services API calls available. Rather obvious, I think, for starting, for stopping, for suspending a trace session, for resuming a trace session, and to get a list of the trace sessions available. What about security? Security is every user can start a trace session, so there is no restriction here. But the username you use when you attach to the services manager basically defines what you can do afterwards. So if you're using sysdva, you pretty much can do everything. If you are using another Firebird user, you can only manage your own trace sessions. So if you start a trace session with a user different than sysdva, then you only can suspend, stop, resume your own trace session, but not other trace sessions. So, yeah. All right. Are there any questions so far? Otherwise, I'm going to show you a few examples with, first of all, with the command line utility. All right, that's pretty much what we have seen already. Then you're able to query the currently available trace sessions with command line utility here, just by providing a list switch. So if we're gonna start this one here, we'll see that currently there are 2 trace sessions running. One is a system trace session. So if you remember, that's the one which you can provide in the firebird.conf file, so that it gets started automatically if the Firebird server starts. And finally our user trace session here, we will see that the session name, which user has started the trace session, on which date, and is it active, is it a system audit trace session, or is it a user trace session. What you can do is, of course, you then can suspend. I have to look up the trace session ID here. It's 5. So what we are using here is pretty much you have to provide the trace session here. And if we're gonna suspend this one here, it's suspended now. So if we are listing then the trace sessions here, we will see that it's suspended. And if we're going to execute here something, we will see that we don't get any output as expected. So if we want to resume this one again, it's again providing this trace session ID. If we re-execute the list, we will see that it is active again. Going back to our query, we'll see that we get trace events here back again. You can stop a trace session and so on. So I think that's quite obvious. So the thing is now with the trace output, it's harder. It's pretty much hard to read. Well, it's not hard to read, but you might get into trouble to possibly detect the things you are really interested in. So especially if you're on a production system with number of connections, a number of users, number of SQL statements, and so on, the generated trace output can get really large, really fast. So the thing is that we need some kind of way to work with the trace API in a more user-friendly way. And this is one opportunity for tool developers like us, just to use a new feature of Firebird 2.5 and simply try to create a tool around that and to try to create a small business around that. So what I'm going to show you is now the product. The thing gets pretty interesting with the screen resolution, but let's see. What we see here on the left-hand side are the registered servers. So if we connect to a server, we will see that we have 2 trace sessions started here, and we have a few projects, so-called trace projects, defined in this area. So what we can do here, of course, we can do the same here, like with the command line utility. We can suspend, we can resume, and so on. We can stop a trace session. So that's pretty much the area what you can do here. You probably want to start a trace session. So what you have to do here is you simply much create a so-called trace project. The trace project is just a set of the properties, the configuration parameters we have seen previously. So you just pick what you are interested in, and you get this output here. It's exactly the same as you use a text configuration file. So what happens here now is, if you start the trace session, you are immediately in the trace session mode. So now if we re-execute, for instance, this statement here, we will see that we still have the output. We still have the output here as shown in the command line utility, but pretty much what we have is we mark new trace events more easily. We have some kind of code folding here. But the most important thing here is that we have a parser which takes the trace output and pretty much parses the output and brings it into a column in a column form, so that things get more easier to read. Let's go through a bit about what information we have available here. We have the event name, for instance. A statement was prepared on this database, this SQL statement, the execution plan. There was the execution time, the whole I/O statistics, which is also available with the monitoring tables, so the number of reads from disk, the number of fetches from the cache, the number of writes to disk, and so on. You also have stuff like the username, role name, the client, remote address, and so on. So you have a lot of information here. Or for instance, when we are talking about some kind of transaction here, the isolation mode, the record version, is it a wait, no wait transaction, is it a read-only transaction, is it a writable transaction, and so on. So there's a lot of information here available. The thing is with the Trace Manager that you can store the parsed output in the included Trace Manager database. So if you have this checkbox selected here, the parsed rows here are going to the Trace Manager database for late inspection. So it's a regular Firebird database, so you can query the logs. So that's pretty useful. That's pretty much the parser, which was quite a challenge because the trace output isn't documented, so it was more or less a trial and go and see how we are doing with the parser. The thing is, there are other things like you can do reporting on the stored trace data, so you are flexible here. You can create your own reports. You can change the existing report. So you are pretty open here what you want to do in respect to reporting. An interesting thing here is the analysis part. So it gives you some kind of multidimensional drag and drop interface to analyze data. So let's see if we go over here. We will see that well, it's just a matter of we have the timestamp here included with the year, quarter, month, and day. So we will see that something happened today with, let's say, there have been 135 records stored in the database here. So, for instance, if you want to get some information on what kind of event types have been involved here, it's pretty much just dragging this one here over there, and you will see that you get some kind of information on what is probably the most frequent trace event type in your area here. So that's especially for analyzing things afterwards pretty interesting and pretty useful. The other thing here is that in the parsed area, as I've said previously, the amount of data can grow pretty huge. So you probably aren't able to, even if you're in front of the application, to spot any suspicious things. So what we have done here is we have called event processing. The event processing is basically allows you to write so-called event rules. Event rules is just some kind of piece of code. So let's discuss this one here. I'm gonna start with an easy one. It's pretty much well, you create a new rule. I've prepared a few, and when creating a new event rule, you can select different rule types. So, for instance, what do you want to do if your user-defined condition is fulfilled? So, for instance, if you want to color a cell in the grid with a particular color, you can do it with this rule type. There's another one, a cell formatting rule, where you, for instance, can make the font bold or something like that. Or if you want to show an alert window, you're able to do that. Or if you want to send an email, execute an application, or, well, you can play a sound. So if you have turned off the monitor, you even get response here if something suspicious is happening. I'm gonna talk here. I'm gonna show you a first example here. It's pretty much we have the events state column here, and it simply tells us that if something executed successfully, it has the value of 0. So if we are going to, we have to reload this one here, and if we are going to re-execute the statement, we will see that, well, it gets, do you get the color? Yeah, okay. That's executed successfully, so it is shown in green. If we are executing a statement which is pretty much wrong, so it can't be executed, the event rule makes sure that it gets colored with a different color. Or even if, for instance, we connect to a database with, I don't know, a user which with a username where the password is wrong, so it's some kind of unauthorized access, we are able to for instance, swap that with our event rule because it got the color red. So if we are going back to the row output, we will see that there are different subtypes here, the unauthorized and the fail, and if there is no thing here, then it got executed successfully. Another example is if you want to detect full table scans, so if your execution plan includes the natural statement or the natural term, it's pretty much an event rule with this code here. So what we are doing here is if a natural scan is happening here, we want to show the execution plan column in red color. So if we're gonna activate this one here and reload, and for instance we are going back to select our customer, we will see that our event rule makes sure that you got that information that there is a natural scan, a full table scan happening here very easily. Another one is with, I don't know, if you're interested in spotting things like commit retaining, because it's might be a problem in respect to garbage collection. And I'm gonna type this one here, then it won't work because I have to reload the event rules. So I'm gonna execute this one here again. We will see that according to our event rule, we are now drawing the event name with a bold color. So that's another example. Well, there's another example with showing an alert window. So if you aren't running the TraceManager application in the foreground and you want to get notified if something happens here, we pretty much say if the execution time of a statement is larger than 100 milliseconds, alert window should be displayed. So if we're going to reload the event rules here and hopefully get a statement here which takes longer than 100 milliseconds, we will see that there's an alert window here over there. So if we go into the information here, we will see that the execution time was around 1.5 seconds. There have been quite a number of fetches from the cache when executing the statement, and there have been a few number of reads from disk. What you can do with the Trace API here, if you inspect these values here, you can also see how efficient is your page buffers value. So probably you have to increase the page buffers value so that you use more RAM for caching pages. An interesting thing here is if we re-executing this one here, we will see that execution time is much lower now. So even for the same number of fetches and the same number of physical reads, that's probably the file system cache kicking in here. So that's probably the reason why it's got executed faster. Well, another one is probably not that useful, but with the execute application rule type, you are able to, for instance, if there is a commit retaining and you want to probably generate the header page because you want to inspect the transaction counters, you are able to do that as well just with the execute application function here. All right. What we also have is the visual stuff. What you see here is can be quite memory consuming, especially if you run the TraceManager for a long period of time, or if you have a lot of actions, a lot of statements happening here. So if you are just interested in getting the data stored in the FB TraceManager database and you want to inspect and to analyze the trace data later on, we have also a Windows service-based application available here, which basically does not include any visualization things. So it's just storing the parsed trace data. And this one is very, very memory friendly. So this one you can even run in a 24/7 environment. All right, that's pretty much a very, very short demonstration because somehow lunch is waiting. The thing is, I want to shortly discuss the available editions. There is a light edition which is freely available. It's pretty much a very user-friendly, for Windows only replacement for the FB Trace MTR command line utility. Then there is the standard edition, which is basically the light edition plus you can connect to remote servers. You have the parser included, and you have the reporting module included, and then there is the enterprise edition, which basically does everything. So standard plus the analysis module and the event processing module. There's also a trial edition, which is the enterprise edition for 30 days. but with one restriction that the number of received passed trace events is limited to a particular number. So that's the restriction here. Well, it's pretty much all I can say in a very, very quick way. Well, are there any questions? All right, everybody ready for lunch? All right, then enjoy.